Alright, so differential equations, well, second order differential equations using variation of parameters. So this is a pretty classic example. So y double prime plus y is equal to tan x. It's a pretty easy one. So we're going to solve it using the wronskian. Alright, so first to the side here, we should probably know that y is going to equal y sub c and the particular solution. And further, the particular solution is going to look like this. It's going to look like y1 u1 plus y2 u2. And y1 and y2 are actually, I guess, the parameters that were varying. I don't know, I guess that's where the name comes from. Not really, I don't really know what I'm talking about. Anyway, let's move on. So let's get started. So if y sub c is equal to it's equal to c1 cos x plus c2 sin x, and that just comes from us taking r squared plus 1 equals to 0, and obviously r equals to plus minus I, and I'm going to skip a lot of details. I hope that's apparent. Anyway, let's move on to the particular solution. So before we do that, it's helpful to find the wronskian first. Wronskian is just a determinant of these two functions. Alright, so cosine x, sin x, the derivative of cosine being negative, sine, derivative of sine being cosine. So this is going to be cos squared x minus negative sine squared x. This is equal to 1. Alright, so let's move on. So there's actually a formula for u1 and u2, and u1 happens to be negative integral of y2 times g of x. Right, so it's going to be sin x times tan x divided by the wronskian, which happens to be 1, so we don't write it in this particular case. Alright, so how do we do this? Guess best thing to do would be you see tan x is just sine over cosine, so this is sine squared x over cosine x. Right, and I'm gonna just omit the integral for now to make things easier for myself. This is equal to 1 minus cosine squared x divided by cosine x, and we can further simplify. That as 1 over cosine x minus cosine squared x divided by cosine x. So this secant x minus cosine x. So we take the integral of that dx, and that's going to give us, okay, I just happen to know the integral of secant x is ln secant x plus tan x, right? And integral of, what do you call it? Integral of cosine x. Integral of cosine x is just positive sine x. So just sine x, and there's a negative sign from here. So that's equal to sine x minus ln secant x plus tan. Okay, so now we have our u1. Now let's get u2. And u2 is the integral of what do you call it? Integral of y1, which is cosine x times tan x divided by 1. So this is just sine over cosine, so this will cancel, and you'll just get the integral of sine x, right? Yeah. The integral of sine x is just negative cosine x, right? So we have our y sub p. Y sub p is just y1, which is cosine x, times u1. u1 is sine x minus ln secant x plus tan x. Alright. And second term, y2, y2 is sine x times u2, which is negative cosine x. So we can factor cosine x out, right? So this is going to be cosine x times okay, so factor out cosine x and here the sin x, these two cancel, so it's just negative ln secant x plus tan x. Okay, so this is equal to cos x, or negative cos x, ln secant x plus tan x. Okay, so from here we just follow this. So y equals to c1 cos x plus c2 sin x minus cosine x ln secant x plus tan x. Alright, and that's the final solution, and it works, I guess. So let's put it in a big box and congratulate ourselves. Okay, bye.